Okay, today we're going to talk about proportional relationships. You've already learned about proportional relationships. This is something you've talked about since probably 6th grade, for sure 7th grade. So we're going to be focusing on what the equation looks like, what the graph looks like, what we can notice about the table, and just talk about these proportional relationships in a slightly different way today. So on your paper you have a graph of y equals 3x. It matches this graph right here. So next to that graph, if you could fill in the equation, y equals 3x. And we're going to talk about some things that we should notice about the graph. You have a little bullet point that says proportional graphs go through the blank. You should know that all proportional graphs will go through 0, 0, or the origin. Your next bullet point says the equation is blank. So looking at the equation, a long time ago, probably 6th grade, you learned that equations that look like this are called multiplicative. It looks like the word multiply. In all these videos, I don't think my handwriting has gotten any better. Multiplicative equation, meaning that there's no constant in the equation. So the only thing we have here is a coefficient and an x. There's nothing added or subtracted at the end. So the equation is multiplicative, meaning there's no constant in the equation. Now we're going to look at the table for y equals 3x. You have the exact same table on your paper right next to your graph. And in the third column, which is not located here, it says y/x. That's talking about this ratio of y divided by x. So if we take that ratio, y divided by x, we would have 3 divided by 1, 6 divided by 2, 9 divided by 3, 12 divided by 4, 15 divided by 5. And if we reduce all of those fractions, that ratio is 3. So at the top above it says the constant of proportionality. That's what this is, because we're creating this proportional relationship between the y's and the x's. And it's constant because it's the same. So that's why it's called the constant of proportionality. Constant is the same, it's all proportional, 3 over 1 is 3. So at the top where it says constant of proportionality, go ahead and put a 3. And then that ratio is called k. So it's kind of like the variable for the constant of proportionality. It's called k. And it just so happens that this constant is located right here in my equation. So the constant of proportionality is in the same place as the coefficient of the equation. Coefficient means the number before the x. So that's another question on your handout. So in this proportional relationship, our constant of proportionality, k, is 3. Another way to think about this proportional relationship is shown below. Y equals 3x. Y varies directly with x, and y equals 12 when x equals 4. So you have a couple things to fill out. It's this terminology that we need to be familiar with. Varies directly. Y varies directly with x, and y equals 12 when x equals 4. That's just letting you know that this is a proportional relationship. you're going to have a constant of proportionality, and it's just kind of describing that relationship, that it varies directly. So another name for that is called direct variation. So proportional relationships are also called direct variation, which is why it uses this terminology of varies directly. So here's a few different examples we can look at to see if we can determine whether it's direct variation or not. So remember, we have to have a constant of proportionality. We need to have this ratio constant of y divided by x. So here we have 12 divided by 3, which is 4, but 6 divided by 6 is 1, and 4 divided by 9 is neither of those. So this does not represent direct variation. Here we would have 1 over 2, which is half. Here we'd have 2.5 over 5, so 2.5 is half of 5, and 4 is half of 8. So this does represent direct variation. Looking at this graph, here's my origin. So we did talk about the origin. However, it's not straight. It's not varying directly. We said that we have no constants in our equations, so this is not varying directly, which means this one is. In this case, our constant of proportionality would be 5, just as a little side note. Kelsey bought 12 donuts for $4.80. So if we thought about each donut, we could write an equation that we could divide this to see how much each donut cost. And it doesn't say that she bought anything else. And so the cost of each donut would be the constant of proportionality, and you would have an equation. So this does represent direct variation. So you should have the whole top part, the notes filled out. Now we just have a few examples to go through so you kind of can see how questions might be asked about direct variation. So in this case, we're going to find a missing value. So we're going to fill in this table. We have the point 636 and the point -3y. So I know that the ratio here of y over x needs to be equal to the ratio here of y over x. So if I take 36 divided by 6, that ratio is 6, which means that the ratio of y over -3 should also equal 6. So in order to solve for y, if I multiply both sides by -3, that means my y value would have to be -18 in order for this ratio to equal 6. So my y value is -18. Moving on to number 2. It tells me that y varies directly with x when y equals 9 and x equals 6. So I'm going to put y equals 9 and x equals 6. Question A asks for the constant of proportionality. So I know that the constant of proportionality equals y divided by x. So that's going to equal 9 divided by 6. We can reduce that fraction to 3 over 2. So that's my constant. Then to write an equation, your handout gives you the format of equations, which remember we have the constant of proportionality becomes the coefficient of x. So it would just be y equals, fill in our k that we found on letter A, 3 over 2x. Then letter C says to fill in the table with some points that would go with this equation. So I can just pick any points for x. I kind of like patterns, so I'm going to choose 2, 4, we have 6 already, 8, and 10. And then because I have my equation, I can just plug in these numbers into my x value to find my y. So remember, 3 over 2 is the same as 1.5. So you could use a calculator if you have one. Your phone might have a calculator, unless you're on your phone to watch the video. But you can just fill them in with me. So if I plug in 2 to the equation, 2 times 1.5 is 3. 4 times 1.5 is 6. Then I have 9. 8 times 1.5 is 12. And 10 times 1.5 is 15. So here we have a table. Then letter D says to draw a graph that fits the equation. So we're just going to sketch this real quick. 2, 3, 4, 6, 6, 9. And I messed up on my graph. Bloop, bloop. 2, 3, 4, 6. There we go. And the graph on your paper, you're able to sketch all your points. This graph is just a little bit smaller, so you can go ahead and sketch the graph. And then letter E says to find y when x equals 20. So it's almost like just extending our little table here. And now we're looking for 20. So again, we can just use our equation that y equals 3 over 2 times 20. So that's 20 times 1.5, which is 30. So that's letter E. And the last part is number 3, to complete the table to make a proportional relationship, also called a direct variation. So first we're finding our constant. We only need 1 point to find a constant. So 24 over 4. So my constant is 6. So then I'm just going to use, we can write an equation from that. We'll go ahead and use our function notation. So f of x equals 6x would be our equation. So if I'm trying to find f of 1, that would just be 6 times 1. F of 3 would be 6 times 3. F of 6 would be 6 times 6. And finally, f of 8 would be 6 times 8. So to finish my table would be 6, 18, 24 is filled in, 36, and 48. That is it for today. Go ahead and fill in your feedback form on the Google Doc from the comments, and I'll see you in class.